Let's take a look at transformations of quadratic functions. Let's start by taking a look at the parent function. The parent function is f of x equals x squared. Okay, and here we have a graph of the parent function. The parent function always has a vertex of 0, 0, and the graph is faced upward. And so now let's look into some transformations of this parent function using what we call vertex form. Vertex form is y equals a times x minus h squared plus k, where hk is the vertex of the graph. And if you're not familiar with vertex form, please see my video entitled Vertex Form, and it goes into further detail about this form of a quadratic function. So when we're dealing with translations, or transformations rather, the horizontal shift is indicated by our h, which is the x value of the vertex. So remember, every ordered pair has an x and a y. The first value is x, and that indicates a left or right shift. If h is negative, or if you see a minus sign in your equation in front of the h value, that means that the graph is translated to the right. And if you see a positive sign in front of the h value, that means that that graph is translated to the left. And it's the opposite, because if you notice, we have a minus in our formula. And so that will mean that if you have a negative, the original value for the vertex is actually positive. But if you have a positive here, that will indicate that the original value for the vertex was a negative, because you would have a double negative. Also, let's take a look at the vertical shift. That is indicated by the k, or the y value of the vertex, and it tells you whether that graph is shifted up or down. A little easier, if k is negative, that graph would be shifted down. If k is positive, that graph will be shifted up. Looking at our a value here, it actually tells us two things. If a faces up or down, if a is positive, the graph is facing upward. If a is negative, the graph is facing downward. And also it tells us whether or not that graph stretches or compresses. So now let's get into some transformations. So what exactly is a transformation of a quadratic function? It is simply the change in the position, size, or shape of a graph. The four types of transformations we're going to look at are translations, reflections, stretches, and compressions. The first type of transformation we're going to look at is a translation, and that is sliding or moving the graph without rotating or flipping it. So we see here we have different examples of a translation. This is our parent function in the middle here, because it has the vertex of 0, 0. We can see that this graph is translated to the right. The middle graph here, we have our parent function in black. We can see that this graph is translated up. And our last function graph here, we can see our parent function, and this graph is actually translated to the right, and is also translated down as well. So now let's look at some examples. The first example we're going to look at is just looking at how these two graphs are translated from the parent function using our k value. And we know that that is the k value because it doesn't have any parentheses. So these would be our k values here. So we have a plus 3 and a negative 3. And if you notice, our parent function here is first, but this second graph, this graph goes up 1, 2, 3 places. And so that shows us that that graph was translated up 3 units. And the last graph here, we have a negative 3 or a minus 3. That shows us that that graph was translated 1, 2, 3 units down. Now let's take a look at some horizontal transformations. And we can see that by the graph, because we have parentheses. And so this positive 3 is our h value, and this negative 3 right here is also a h value because it is inside the parentheses. So once again, we have our parent function here, our vertex of 0, 0. But here we have a vertex here of negative 3, 0. And so if we look at our equation here, we can see that our vertex our h value would be negative because remember I said it would be the opposite. So in vertex form, the original formula has a minus sign in front of the h. So if that's a +3, that would mean that the original vertex or the original x value was a -3. So we have a -3, and we do not see a k value, so our k value is 0, and so that actually matches our vertex here. And that graph was translated to the left 3 units. All right. Right here, we have a -3. And so since we have again our minus in the formula, that indicates that the original 3 was a positive, no k value, so it's 0. And we can see here that our vertex is 3, 0. So this graph is translated 3 units to the right. I'm going to write it down here. So right 3 units. So with these 3 problems here, we want to actually analyze the transformations or the translations without actually having a graph by simply looking at the h and k value. So example 3a here, our vertex, it's easier to see the transformation if we know the vertex. Our vertex is -2, 0. We don't have a k value, so our k value is 0, and the h value is -2. Again, because you have a positive here and there is a minus in the formula, which indicates that the original 2 was negative, because when you plug it in, that double negative makes a positive. So that -2 tells us that that graph is translated 2 units to the left. Nothing changes with our vertical change because we don't have the k value. If we look at B, we don't have any parentheses, but we notice right here that we have a 5. So our vertex would be 0, 5. There is no h value. K, it doesn't, it's a plus k, so whatever sign you see here, that is the sign we use. It's a +5, so it's a +5 in our vertex, and that indicates that that graph is shifted 2 units up. Our last one here, our vertex is -1, -6. So we got a +1 here, so original 1 was negative, and then we got a -6. So this shows that this graph is translated 1 unit to the left and 6 units down. Let's take a look at reflections of a quadratic function. A reflection flips every point of a graph across a line called the line of reflection. So what indicates a reflection is when a is negative. That graph is flipped over the x-axis. So the graph we have here, we have a minus or a negative in front of our parentheses here. So just like our a value in front of our formula here, if you have a negative number in front of your parentheses, that shows that your a value is negative. That graph is flipped over the x-axis. Not to get it confused with this second equation here, we have a negative in front of our x. Since that is inside the parentheses, that graph is not flipped over the x-axis. So we would have to have a negative on the outside of our parentheses in order for the graph to be flipped over the x-axis. Now we're looking at vertical stretches and compressions. If the absolute value of a is greater than 1, then it is a vertical stretch, meaning the graph will get more narrow or narrower. An example here would be if we have our a here, it's -2, but remember it's the absolute value, so we're just looking at the 2. So that is greater than 1, so this graph will actually be narrower than the parent function. If the absolute value of a is a fraction, or between 0 and 1, it is a vertical compression. That graph actually is actually wider. It is compressed, and so our a here is 1/3, so this would be a wider graph. Let's analyze these transformations of the quadratic functions here, looking at the stretch and compression. So we see here that this second graph has a value of 3. So that is greater than 1. And we can see that this graph is actually more narrow than the parent function. So it is stretched vertically, more narrow or narrower. And our last graph here has a value of 1/3. and that graph is actually wider than the parent function. So we can see our parent function here, but this graph is actually wider, and that is indicated by this fraction here, which is our a value. So let's piece everything together with our transformations. So example 5a here, we have the graph y equals -1/2 times x plus 1 to the second power. I like to get the vertex first. So the vertex of this graph is -1, 0, because that is going to be the opposite. So -1, no k value, so it is 0. So looking at the vertex, that shows that that graph is going to be shifted 1 unit to the left, no k value. It is flipped over the x-axis because we have this minus sign here, so our a is negative. And it is compressed by a scale factor of 1/2, so that graph gets wider because we have that fraction there. Let's look at b. Our vertex is -3, 7, so that graph is shifted 3 units to the left, 7 units up, flipped over the x-axis once again because we have this minus. And it's also vertically stretched by a factor of 2, so that graph is narrower than the parent function. Alright, so these are the last 2 examples I'm going to do with you before I have you try some problems on your own. So for these last 2, we want to write an equation to represent the functions. So for a, it says this graph is vertically compressed by a factor of 1/3, so that is our a. Then it is translated 8 units up. So remember, up and down, that is our k value. We do not have an h value, so that tells us that we're not going to have any parentheses when we write our equation. So our a is 1/3, translated 8 units up, so that would be y equals, our a is 1/3, so 1/3 x squared. 8 units up, that would be plus 8. So remember, if you can recall from standard form, remember standard form is ax squared plus bx plus c, and so our a is also in front of the x squared term. Alright, so since we don't have a horizontal change, there is no parentheses. Now let's take a look at b. It says it is vertically, let me box this, vertically stretched by a factor of 2, so that is our a. It is reflected over the x-axis, so again that is going to make a negative. Then it is translated 4 units to the left. So if it is to the left, that would mean that my vertex, original vertex, is -4, 0. My k value is 0 because there is no change up or down, but if it's translated 4 units to the left, that tells me that my vertex would be negative, or the x value of my vertex would be a -4. So when I write my equation here, my a is 2, it's going to be negative. Inside my parentheses, we're going to have x plus 4 because we have a -4 and we also have a negative in our formula, which indicates a double negative. Remember, a negative times a negative is a positive, so that would be a plus 4. And we have to put our squared here. There is no translation up or down, so we don't have a k value. And so we've written the equations for these 2 functions here. So the last set of problems here I would like for you to try on your own. So go ahead and pause the video and try these problems on your own. So go ahead and check your answers here. Hopefully you got them all correct, but go ahead and just pause the video and check your answers. If you did not get them correct, make sure you analyze my work a little bit more once you pause the video. Okay, so we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are vertex form of a quadratic function, also introduction to quadratics. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.